All right. Good morning, everyone. Today we are going to spend a little bit of time looking at two-dimensional motions and our conceptual understanding of how that works. And our goal for today is to get through these 3 points. The first one is that two-dimensional motion is a combination of movement of an object in two directions or two dimensions happening at the same time. The second point is the horizontal and vertical velocities are both acting at the same time, but they are not related to each other. And the third thing is during flight, the only force we will consider acting is gravity. All right, so those are our 3 objectives for today. And we are going to start off by looking at objective number 1. So this is you. You are there, you're standing on the ground, and you're spending a lovely afternoon outside, and you see a mango hanging from a tree, and you really want that mango. So here is our tree, tree, and off of this branch, it's a big mango tree, off of that branch that comes off, you see a mango hanging. And so you take a rock, and you throw that rock, trying to hit that mango, and it follows this path, and it goes and falls all the way back down to the ground. So, you tried to hit your mango, but you missed. You were a little bit short. And whether or not you hit your mango is irrelevant for today. What is relevant is the path of the rock that you threw. So we're going to look at this path. You can see how it is a curve. That curved path is called a parabola. And if you know that math term, that's great. If you don't know that math term, that also is great. We will come to learn that term in a little bit more detail very soon. But we're going to specifically look at 2 points in time. At one point in time, your rock was here. At another point in time, your rock was there. And so we're going to zoom in on that. And we're just going to take that and expand those. So at point in time 1, rock is here. At point in time 2, rock is now there. So, in order for that rock to go from here to here, it has to move some direction to the right, and it has to move some direction up. So that direction to the right, that is horizontal, and we are calling all horizontal motion a change in the x dimension. So that horizontal motion is a change in your x position. It was here at some point, now it is here at some point. So we have some change in position of x. So that's a delta x. It also was going up. So that is some change in position y. And that is our delta y. So as it was moving, it went a little bit to the right and a little bit up. So it had some change in position x and some change in position y. And that gives us a result of a change in position at some angle to the up and right. So that is our first thing that we need to look at, is that there is a there's a movement in two directions at the same time. If we look at another point in time, let's choose that point to that point. So we're going to blow that up as well and say, all right, now my ball at a different point in time is here. And a little bit later, very short while later, it has moved down a little bit. So my object, my rock, my ball, whatever I threw at the mango, is still going to the right. But now, instead of going up, it is going down. So it still had some delta x, some change in position x, and it has some delta y. Are those delta x's and delta y's from point in time 1 to point in time 2 the same? Maybe, maybe not. We know the y's definitely are not. One is going up and one is going down. But to the right, that was just me sketching it in. We'll have to find out if that is a change in position, if those are the same or not the same. But that's not the point for right now. So at this point in time, my overall change in position is now down and to the right. And so it went from this point to this point, some change in position to the right, some change in position in the vertical dimension as well. So when I was going up, so in this part, your delta y would be positive, increasing. On this half, your delta y would be negative, decreasing. So that gives us two-dimensional motion is a combination of movement in two directions at the same time. So that motion is divided in half. The next objective for us today is the horizontal and vertical velocities are both acting at the same time, but unrelated to each other. So we have to remember a little bit about velocity. And I'm going to define velocity the same way that we have always defined velocity. Velocity is displacement over time. Displacement, we have always said displacement is delta x. So if you're moving horizontally, you would have a delta x displacement. So if I'm moving, I have a velocity in the x dimension, v of x. Then that is change in position in the x dimension over time. I also can move vertically in the y dimension. V of y is delta y over t. So any displacement in the y dimension, moving up or down, over time. So I can have a velocity in x and I can have a velocity in y. Do they relate to each other? The only thing that connects them is time, but the distance you travel horizontally and the distance that you travel vertically are very different things. So if I go back to our example, zoom in on this, the rock went from here to here. That took some amount of time. So if I am going to define this as a velocity, at this point in time, I would say, all right, that took 0.1 seconds. My time is 0.1 seconds to go from here to here. So my velocity of x is my change in x over time, and my time is 0.1 seconds. And I could find my velocity of y by how far did it go up, my delta y, over time. And I could do that same thing at time point 2. You'll notice that the velocity, how it's changing, moving, its rate of change going vertically and its rate of change horizontally are completely different from each other. They are unrelated. I can make it go super fast horizontally and that would not affect what it's doing vertically. I could make it go super fast or slow vertically and that would not change what it's doing horizontally. So these two velocities are both acting at the same time, but they are unrelated to each other. And this brings around our third and final point for our conceptual understanding of what we need to do today. During flight, the only force we will consider acting is gravity. We all know that gravity, I will represent gravity with a different color. Gravity will be green because, G and G. And gravity is pulling down on this rock at every point in time. So no matter what point in time I look at, there is gravity. Gravity is always pointing down. And gravity is a force. And when you have a force, all forces, all net forces, cause accelerations. And what is an acceleration? Acceleration is a change in velocity. So there's the first thing, there's the second thing. Gravity is a force. All net forces cause accelerations. And what is an acceleration? Remember that an acceleration is a change in velocity. So if I were to go back and consider what is happening throughout this entire time, we're ignoring air resistance and ignoring the wind because there's too many variables that goes in with that. We know that gravity is always pulling down. So our speed of y, velocity of y, will be changing because there is a force in the y dimension. But our velocity of x, how fast it's moving horizontally, there will be no change in that. So between this point and this point, if that was 0.1 seconds, the velocity would be the same in the x dimension as it would be over here. So the velocity in the x dimension is always constant, where the velocity in the y dimension is always changing. Thank you for watching. Hopefully you found this a little helpful, and we'll talk some more later.